we know that innovation starts with several peoples who are very ambitious and very visionary in in laying out the foundation of technology. For example, in the technology of the Internet of Things, which is one of the big pillars in OIR, we are seeing that the father of IoT, because the term Internet of Things, if most of us maybe have just heard about this a couple of years ago, the actual thing is that it has been coined by Kevin Ashton since 1999. That was about nearly 21 or 22 years ago. That was a very long time ago, and yet maybe some of us only realized this term a few years back. In fact, in Malaysia, when I did a study, I understand that Malaysia started to Google this term of Internet of Things in 2014. So we are quite late in terms of understanding IoT, but maybe not too late. That's what I hope to. And then we have heard about this new revolution, the fourth industrial revolution. Even the term fourth industrial revolution, before it came into realization, there's this person, Heinrich von Schill. We call him the father of Industry 4.0. In German, they call him the Industry 4.0. The reason is that at that time, in 2009, Germany faced a challenge that they want to transform the manufacturing industry, and they use the digital transformation, and they come up with a blueprint, a policy for the country to transform into Industry 4.0. So he mentioned that this Industry 4.0 is actually the fusion of many technologies. And we are seeing that, the world of digital, the world of virtual in the internet world, and the world in the physical world is going to fuse together. And this is where what we call the cyber-physical system. What we realize is that it is important for a lot of organizations, companies, businesses, have to transform their business, because the main reason is that every 3 to 7 years, they got to understand that they need to reinvent themselves. Because without this reinvention, without this transformation, they're going to get obsolete. And we have seen that many companies, only 90% of these companies are still in existence today. And this is the reason being because these new technologies can obsolete a lot of your current products and services. And this is what happened. I still remember the time when, I'm carrying a bag with a lot of cables, with a lot of gadgets, just to have all these facilities with me. Carrying a PDA, a phone, cameras, all in digital form. It's all in various digital, several different gadgets. And what happened now? We are seeing smartphone is very intelligent enough. It's very powerful, and all the features that have been in separate gadgets are now being integrated into one. And this is what the power of digitalization, that's what we are facing now. So it's very important for us to know that impact, because without this understanding, we're going to be behind. So it's very timely for this kind of area, talking about the innovative applications, the inventions that we need to take place. This is where we lay out this foundation for our next generation. When we take a look at this, the 4 eras, or what we call the industrial revolution, and sometimes we also wonder why we call it a revolution, because revolution is a very disruptive and very sudden change. What we don't want is that we're going to be in a slow, gradual transformation. That is called evolution. Of course, in certain areas at one time, the technology is quite slow, so it will evolve slowly. But what we are seeing now is a very exponential growth, because this technology affects the other part of the technology that can increase the pace of innovation faster than before. And if we take a look at these industrial revolutions, we do understand that in the era of Industry 1.0, it is very much focused on we use mechanization, with water and steam engine as the way for us to power the factory. But when we realize that electricity is being discovered, we can do a lot of more mass production with the help of electricity. In the industry 3.0, this is where the electronics have, we create electronics, ICs, software, internet is being introduced. In industry 4.0, this is where all this intelligent networking, as I mentioned to you just now, the digital, the cyber, the virtual world and the physical world is integrated together. And that's what we're having now. But when it was coined the term of industry 1, 2, 3, and 4, it is very much related to one particular sector or industry, which is the manufacturing. Now we realize that the whole of technology now goes across the whole economy. So that's why we need to come up with a better look into how technology like blockchain and all that impact us. So that's why they call this 4IR. So let go into another different aspect of what 4IR is. So in different countries, they have different names. For example, when Japan started off their journey into 4IR, they don't call it the Industrial Revolution. They look into the human aspect of the way that their society evolve. So in the society 1.0, they look at the way that we find food is through hunting. That was the old ages, the Bronze Age most likely. So when it is in the agricultural society, we are in 2.0. That's why we have people in the rural areas. And then they move into the urban areas. You see the industrial society comes in place. And then at the 4.0, society 4.0, they feel that information is the key. The internet is the one that makes us, a lot more knowledgeable. We are trying to find information through internet. But in 5.0, they understand that instead of you, the humans, the people are seeking for information, the information will come to you because it's very intelligent enough to understand what the human wants. So it's more human-centric in a way that if you browse certain things nowadays, instead of you browsing other things, this thing comes to you. Well, after you go for shopping in Amazon, Amazon will propose you a lot of other things which is to your interest. The reason being, they understand your profile. That's how the new society is coming now. And then if you take a look at Malaysia have started off our journey in there's a lot of policies in Malaysia, a lot of blueprints, a lot of documents have been put in place. But I'd like to mention a few of the notable ones which is related to the 4IR. In 2014, I still remember the days when we set up what we call the National Internet of Things Strategic Roadmap. It is to lay the foundation of, how we can go out and create an ecosystem and also businesses to increase the whole business in Malaysia, GDP, using Internet of Things. So that was in 2014. And we need to understand that in 2016, the World Economic Forum has started off talking about the fourth industrial revolution. Yeah. In 2018, we launched our Industry Forward. And that was meant to cater for the manufacturing sector. That's why we realized that it's not enough for us just to cater for this industrial revolution in the manufacturing sector because it goes across other sectors. And then in 2020, we come up with what we call the MICE STIE, Science, Technology, Innovation and Economic. So to lay out the research, the R&D, which is more important, the impact the economy of Malaysia. In 2021, recently, early this year, we came out another what we call the Malaysia Digital Economy Blueprint. So if you take a look at this journey, that is actually the story of that before we even go up to the fourth IR. So when we take a look at the industry forward, in that factory setting or manufacturing setting, we feel that there's only some technologies which is related to this sector. So it doesn't mean that other technologies are not important because maybe it's not relevant to them. So they have identified like AI, big data analytics, augmented reality, additive manufacturing, Internet of Things. These are some of the technologies which is related to manufacturing sector. And of course, when people say why our technology like blockchain is not being announced here and there, that's why people get sensitive in terms of that. But then we also realize that these other technologies also impact the rest of the sectors. So if you take a look at on the left side, there you can see the y-axis. We take a look at all the new technologies and that go across all the socio-economic drivers. Regardless whether you are in education, agriculture, medical, culture, or energy, these technologies have an impact to our lives. Yeah. So it is also important for you guys, especially in the universities who wants to get grants, for example, you must be in line with the MySDIE. Otherwise, it's very difficult for you to get the grants too. So that's my giving you a tip, whenever you want to go out and, justify getting grants, you have to take a look at how you are in line with the current government's initiative. And then we realized that there's something missing last year when in 2020, we found out that we want to go fast, but yet there are certain things which is lacking or we have a very big gaps. Remember the days when COVID-19 hits us in 2020? Everyone is working from home. Everyone, all sectors, even education, working industry, suddenly we work from home and we are out of touch because we are so much in a brick and mortar kind of companies. We always need to see people physically and suddenly now we have to be everything on remote. And that's when we really understand that digital is so important. Internet is so important. Not only the coverage of the internet, we also want this kind of speed which can support us in even what we are doing now here in this conference. Without the right internet connectivity and speed, we wouldn't even get a very good video conference. So that is one of the things that the government realized that we have to go back a little bit, step back and see that how far are we in embracing digital. So even before we go to the era of IR 4.0, digitalization needs to be taking place. Even before digitalization have to take place. What I mean is when we are talking about digitization, all the analog information have turned into digital first. Even before we talk about new workflow in terms of digitalization workflow, even before we put in intelligence into our digitalization workflow. So we have to digitize first, then digitalize, then we can transform to the IR 4.0. And that's when we understand that, hey, there's a lot of other interested parties who wants to know that 4LR should be cover the rest of other sectors. So that is on the 1st of July that we have launched this. And the aspiration of this national 4LR policy is to look into two matters. One, it is very human-centric or society-centric. That's like what Japan is looking at people first, ensuring that the technology that we embrace is something that can help us in terms of our living, the way that we work, overcome all the social stress, that's happening now, improve the quality of life, focus on happiness, rather than technology is trying to take our jobs. We shouldn't get worried with that. And then we are looking at the whole of nation approach. There are three parties to be really get involved into this. We need to take a look at the government themselves. The government needs to be able to facilitate and enable more innovations. So we have to put these policies in line to ensure that ecosystem can grow. We want to see that the businesses themselves to be very, to take a step up faster in terms of embracing new technologies, because otherwise they cannot be very resilient. They cannot even become very competitive. They're going to get lost and, by the end of the day, become obsolete. And then the people themselves, the rakyat, we want to ensure that they are more aware about what's coming, what's the new technologies that's coming to them. So this vision and foundational technologies which the government have put in place, have put all the right trust, the relevant sectors into place to ensure that everyone works into one vision. So the policy trust, for example, they have 4 policy trusts to ensure that the rakyat themselves are equipped with the right technologies, the right knowledge, the right skills, and what we are doing now, and see that the whole nation are fully connected, the right infrastructure that's going to be put in place to ensure that the regulations are so agile, because we don't want all regulation to stifle innovation. We want to accelerate the 4th industrial technology adoption and also creation. So we need to also create that ecosystem. So there's what we call the 4 policies, different 16 strategies, and 32 national initiatives. You can go this and find this in download this document from the National 4IR policy to understand more about what are the different technologies or strategies. So what they have done is that they just lay out 5 of these technologies. One is the Internet of Things, artificial intelligence, blockchain, cloud computing and big data analytics, advanced materials and technologies as the foundational technologies that can support different sectors. So now no longer we talk about manufacturing sectors, we talk about transportation, we talk about healthcare, education, agriculture, utilities, finance, professional, scientific sectors, wholesale, tourism. All of these are very much affected with all these technologies. So we have that opportunity now. What I've seen in the projects that have been displayed under area covers a lot, and it covers a lot of these sectors. You can group them and say that, hey, my project actually have impact in making sure that we stay relevant to this. Yeah. So it's congratulations to all of the researchers out there. So when we talk about all these sectors, there are certain sectors who take forward thinking. So they, like construction, for example, they understand that industry forward is only meant for manufacturing, but then they also realize that they should be doing this too for construction, because we have been talking about how construction is using manual labor, foreign labor. How can we reduce the number of foreign labor, use automation and all that? So they have come out with their own 4.0 blueprint. So this is what they call it, strategic plan from 2021 to 2025. So I was involved in that too. And from there, they identified about 12 technologies. So it doesn't matter whether, if you're in education, you might identify your own strategic technologies or foundational technologies that you feel. Yeah. So it's good now that the technologies now is being defined, and we, the industries out there, is waiting for these new talents to come out. Okay, that's one thing that which I love to talk about. We have been talking about the whole ecosystem, encourage innovation and all that. Innovation will stop if there are certain factors stifle the whole innovation. We are not supporting each other. So one way for us to support each other is to try to understand how all parties needs to work hand in hand. We understand the university's role, the industry, we have to understand the market roles. So in order for us to do any research which is going to be sustainable, we have to ensure that we are solving the market problems. Solve the market problems, not doing this for the sake of doing research. No, you must solve the market problem, because from there, the industry will carry this product and they will go to the market and they will have revenue out of that, making that as a business. Okay? So, but the industry doesn't have all the time to do the research. So they will need the support of the university to come up with that research and prototypes. So what we are seeing now is something like this. So the research, the university will do the R&D, understand the industry problems, come up with an output, maybe an alpha prototype, which is lab-based. You're good enough for you to work with the industry, turn that into a prototype, which is called a beta-based, where you work with the right customer to test out whether there is a need that's really solve a problem, solve a right pain point. There's a traction with that. And then the industry is able to sell this to the local market. But of course, it should be local, because if the local companies or the local users are not buying from the local companies, then it will stop. The journey stop. It will end there, because what we need is the local to support the local industry. And from there, you will see that the industry is going to be sustainable. They will have a longer runway for them to stay afloat, because if you're not buying from them, they cannot stay afloat. But if you still buy from them, they still have revenue, they can still grow, they will pump back the money into their product roadmap. In order for them to create a product, they need the talents from the university. They need to push back these industry problems and share them with the universities, and the universities will support that. So you will see that it goes again, this cycle of the customer feel that the roadmap is always there, so it will maintain that loyalty, and the industry will pass back their roadmap to the universities, so the universities will continuously develop their own R&D, the R&D. So that is what we need in the whole ecosystem. By doing this, we become a producer nation. Rather than we just buy from other countries, then we become a consumer nation, consumes other things. We will no longer, getting our people to be trained and have a value of the idea of becoming more creative, innovative, or become a designer. So with that, then the salary of the engineers, the programmers becoming higher and higher, because they create things. If you buy things, maybe you don't need that kind of skills. So this is what is important for us to have this ecosystem. So if we feel that this OIR is so important and we want to have that journey, how far are we into that particular journey of OIR? So which era are we in? I might ask this question back to the whole audience. If I'm in the big hall, I might ask the question and ask, have a raise of hands. But here, I don't have that capability to see the results. But some people will say that, I'm already in IR 4.0. Are you sure? So that's a question. So let's take a look at, your everyday life, the way that you cook. Tell me, are you cooking in the way of OIR? So if you take a look at, if you are cooking in the way that using fire, utensils like this, charcoal, coal and all that, then you are still in era 1.0. If you are in the 2.0, you might use an oven, which is electrical powered, is 2.0. In 3.0, you might have an oven, which is much better, have a way for you to program it. If you want to barbecue, you want to cook cake, or you want to defrost, they have programmed the units, and you can in 3.0. But in 4.0, the way that we cook is the way that, in 3D printing, people print food instead. So are we in 4.0 cooking? So the way that we teach, the classes that you have been doing now, okay, maybe 1.0, before the era of pandemic, everyone is using the whiteboard and the blackboard and all that. In 2.0, you might even use an OHP projector, with plastic transparency to teach. Or 3.0, you might use online, what we are doing now. This is online webinar and all that. In 4.0, are we using, and the kids are using augmented reality, virtual reality to teach? Are we using robots as the teacher for us to teach the audience? No, we are not. Maybe we are still 3.0. So the way that we transact, are we still the 1.0 way of doing transaction with buku cukai lima? The way that we transact using, a calculator or even a cash register, or using a credit card in 3.0 online, or the e-wallet way of doing things transactionally. So in most cases nowadays, we are good in doing transaction now with Grab, e-wallet, on touch and go. So we are 4.0. That's good. But there are many other sectors are impacted in 4.0. We have to assess ourselves and be true to ourselves. Are we already in that stage? If we are not even having an internet in our business, we are still not 3.0. If we are not truly 3.0, if we are not truly using digitalization, we don't tell that we are already 3.0. If we are, if we are doing transaction, for example, I'm doing some claims, and these claims require for you to sign off, and this sign off required to print out a form, and you have to sign off, and then you have to scan it back, and you have to send it back to the relevant party. That is not truly a 3.0, because it involves manual papers, and then you have to digitize it back, and then you have to send it back, and then people will have to print it back, and then this involve from 3 to 1. 3 to 1 is maybe not even maybe 1.5, right? So where are we now? So it's actually 2.7. When we talk in some areas in the manufacturing sectors, they are 2.5. So not even 3. So in order for us to jump into that 4.0 thing, we have to be at 3.0. So people worried that new technologies like this can replace their jobs, taking over the place of, like the droids, androids, the Sophias, the Simons, can replace people, even the astronauts, and all this will be happening. And a lot of times people see that, but we didn't realize that there's a lot of things that we do it earlier is because technology is not in place. And the things that we do very dangerously, dirty things, demeaning things. So all of these things are, because of people is not there, and because of technology is not there, you have to send the people, and it's very dangerous. People go to war by sending robots. People go to do help emergency in a nuclear plant and all that. They send robots, to defuse bombs. They send robots too. So these are the areas where these technologies can help us. So in terms of technology-wise, we also feel that there's a lot of challenges that makes us feel very slow in terms of making that transformation. Previously, I talked about maybe 4, but now I see that maybe 9 of these challenges are already in place with us. So if you take a look at, even at the start, at the early stage, people have difficulty to even define the business case. The traditional way of buying things, the business model is no longer valid. For example, you buy things and then you deploy things. Maybe you have to change your business models. The way that we have to rethink the way that the new processes that come in place, because it will going to obsolete the whole the current process. The actions that need to be taken, and the culture of the organizations need to be put in place. The mindset transformation, new talents, to learn, unlearn, and relearn new things. The change management need to happen in the organization. People are scared about their job security. People are trying to control their particular department and don't want to share the data. And this is where you cannot break down the silos. So sometimes you also need pilot projects for you to get convinced, and you have to start small. So if you take a look at innovations and inventions that you're going to put in place, all the projects that you have laid out in this event, somehow it must solve certain problems. And if you are proposing your solutions to the organizations, there are 7 M's that you can have impact in the organizations. So I'm not sure which M's that you're going to have that impact, but just take a look at this 4IR, how it impacts the 7 M of the business. The first M is the manpower. Are your innovations going to increase the productivity of the manpower, or even lowering the cost of manpower because of you can do a lot of remote things? You can reduce errors, then you can increase productivity. You can put some security element that you can make better safety for your manpower, your staff. Yeah. The second M is that the materials that you have, very expensive materials that you put in the warehouse, for example, or you want to have this transportation from the one place to another place, you have to ensure that the warehouse is not overstocked or understocked. So you have to ensure that the quality of goods when they are traveling, arrives on time, with a very good condition. So you put sensors to detect all of them. So materials is the second M. The third M is to take a look at the expensive machines that you have to ensure that it runs continuously without any failure, or if there's a failure, it will inform you. So you can have this predictive maintenance. You can reduce error when you see there's a lot of errors coming in. So you put certain sensors or monitoring that sensors, monitoring the machines. Or you can understand that these machines are underutilized. You can even rent the machine to other people who can use the machine during the idle time. Yeah. And then if you take a look at the fourth M, the method, because we understand that when it involves human, the processes every time it falls short because of human in between. And it didn't sign, if this person didn't sign off, your whole workflow is going to be disrupted, and your KPI will not be met because the person is no longer there or is absent or whatever. So if you put machines automated, so whenever there is certain things need to be triggered, automatically it will trigger a contract, for example, using blockchain to trigger that contract. Yeah. So no one is in between. So it becoming more agile, reduce all that red tapes that we have. And then if you take a look at the market, because the problems that you have now is the similar problems that you can have, that solutions can be offered to better or bigger segment overseas. You take a look at sometimes the products in organizations, their business is so stagnant, there's no way for them to increase their or to value add the product. But with technologies like this, you put sensors, now suddenly your products have a better way to inform the customers or the factories when it's going to need service, when it's need to tell the end users that, so become a connected product. So you can create new products and new revenue stream. Yeah, a new business model is going to happen, and so on and so forth. And finally, you will see that because of the data that is being generated from all the relevant machines, assets, and all that, it makes a better decision-making process for the management. Now it's more transparent and real-time. Rather than you have to print out the results in every week, now you can see that, open up a dashboard, you'll see that instantly. So this, I hope that these 7 M's can go across to all the projects that you have today in IOYA. And of course, in Internet of Things, it's normally about assets. Because Internet of Things is all about understanding the assets condition. Yeah. So meaning to say, if you have a very expensive asset, important assets that you want to monitor, you can put the right sensors there. If the health, your health is an asset, you put a wearable sensors, a wearable device, you can monitor the blood pressure, heart rate of the individual, you can monitor from remote. If your goods is an asset, you can put sensors that temperature, humidity in the van or in the lorry and so on and so forth. If your car park is an asset, if your vehicle is an asset, you put a GPS, you know the location of the vehicle, the location of the empty car park, and so on and so forth. So that is just a very simple way of understanding. If people ask you, how can we start in our IoT journey, for example? If people ask me, let's IoTize my business, I will ask him again, what's the biggest asset that you want to monitor? And that asset, you got to put sensors on that. So this is how I think people get, because my main area is mainly in the IoT. I will not talk about the whole 4IR technologies, but just take a look at the IoT aspect. The IoT simply have these 4 main components. You must have the sensors. That's critical. Without sensors, don't call it IoT. So all the analog things now turn into digital, and a lot of sensors nowadays. You have humidity, temperature, proximity, accelerometer, gyrometer, compass, even magnetic meter. So everything in your phone have more than 18 sensors inside that. Yeah. Then connectivity. How do you send your data out from fixed network, or you can send to wireless? So of course in IoT, because it's very small devices, you need to put wireless sensors put everywhere. So it can be from a body area network, local area network to wide area network. And then you have you need a platform, or what we call a middleware, for you to aggregate all the data that comes from many sources. They have different forms of protocols, they have different format and all that. to be parked onto a single platform so that you can manage the devices easily. And then from the data that you have collected and the devices that can manage, you need to share the data out. So you create an applications analytics by allowing other people to extract the data using API. Yeah. So you can create your own workflow. You can do artificial intelligence, which you can do like deep learning or machine learning from the data you have collected. So it depends in which area, because not all of us can have all the four components. You might be expert in the electronics part, but you're not the expert in the middleware part, or you're not even expert in the AI part. So everyone is complementing each other. So that's why I think like projects like this, sometimes if you have a 1 year project, you can only have one component to assist you, another person have to assist you in other components. So if you take a look at the IoT maturity, we understand that IoT evolves too. So it's not like, you have IoT only for monitoring purpose. IoT can go from monitoring to control to optimization and autonomous. In every aspect of your project, you can evolve it into different pieces. So for example, if you're monitoring cars, you can make a new business, what we call car monitoring. The GPS, you know the location of the car by using an app. And then if you put a way for you to actuate, you can control the car. You can immobilize the car. When someone steals your car, you can stop the engine. You can make a car security company. If you want to do a car workshop maintenance, you can put sensors inside the car, or you have an OBD that monitors the fuel consumption, battery, tire, and so on and so forth. Once it reaches to a certain threshold, it will inform the workshop or inform you that you need to send your car for maintenance. So that is for predictive maintenance car. So every aspect of this growth or evolution or maturity, it brings new businesses. So it disrupts previous business. For example, now we have autonomous car. So when every cars have a lot of sensors, LiDAR, you have whatever sensors in between inside the car that is, and even communicate with other cars, with other infrastructures, it become autonomous. It transformed the whole business. Taxi at one time, it was everyone can become a taxi driver, right? When we have Grab, we have My Taxi, Grab, we have Grab, we have other e-hailing taxi service provider. At that time, you see that everyone is becoming a taxi driver. But now when there is no taxi and the taxi drives by itself, you also disrupt another aspect of this job security. Even in US, they mentioned that 10% of the jobs might be affected by autonomous vehicle, because it's not only aspect the taxi or the car, but also the helicopter, the cars, the normal cars, or even the lorry, the trucks, will become all autonomous. So even when there is a flying taxi, it changes again, transform again the whole of the business. Yeah. So you just imagine now, instead of having a taxi, now you can always fly on a taxi. So with this new technology, also it's not that easy for us like innovators. We always want that, hey, I have these new things, and why is it so difficult for everyone to embrace it, right? So you have that challenge too. I mean, all of us have that challenge. The startups, the people like, to build new technologies face these challenges whenever they build up new products which no one have ever seen before. So that's why we need trials. So trials are required first because, of course, you need to understand the technology maturity. Is it mature enough for you to test it out into commercial market? You want to see the market adoption, how people embrace this new driverless taxi. When the taxi stop, no one is there. So would you like to take the taxi or not? The business model, how people are going to pay instead of buying things because of the features or subscribing this. Maybe it's an outcome based. People pay because of the outcome. I give an example. People buy a water pump because they want to transfer water from one place to another place. But what if the business model is outcome based? You will pay based on the volume of water that's being transferred. So you don't pay because of you want to buy the pump, you pay because of the volumes to transfer. That's how the outcome-based business model is. And then the policy and regulatory. People get worried now when a drone is now carrying people, a drone can carry parcel. Where can the drone fly? Is it everywhere? Who can fly the drone? What are the things that the drone can carry? So this involves a new regulation. When the car is now doesn't look like a car, so maybe the regulatory need to change, because vehicle, maybe in what being stated there is a car must have certain tires, number of vehicle must have drivers and all that. But that now doesn't have any driver. So regulatory and policy needs to change. So we want the regulatory to understand this new pace, and they need to allow innovation to take place, rather than to say that, hey, I don't want to do this because people are now scared. So you are stifling the innovation. So regulators have to take that role. And then you take a look at the levels of pyramid, we take a look at the value pyramid. If you take a look at the data that you have collected, you need to understand the data that they collected here is about, is going to be shared, or is it going to be owned by you, or you're not going to make it private. So you have to really identify the ownership of the data. First is whether personal, whether it's private, public, or no one else, people make it commercial. So data alone is meaningless if data is purely symbols that you carry. It doesn't mean anything, it's just numbers. But if data can transform or can answer the questions of who, what, where, and when, it becomes information, more valuable. People pay more for that. And then people can pay higher if it can answer the question of how, it becomes knowledge. People can pay higher, it can answer the questions of why. So mostly organizations want to understand why my business is down, why my product is low, why my product is suddenly, product is always down and all that. So with that, you can find the right data by putting in the right sensors. So to do that, you need to have a lot of information that comes in place that will help you in terms of gathering insights. So you must have like this IoT platform that can blend various data from different sources. For example, in smart cities, you might need to take a look at the whole dashboard of the city about the home, waste, health, transport, and income office. You must have different sensors that goes across. So you don't want to go into silos. If people want to create new applications, they can blend the data from different places too. So with a single platform, it's easy for you to do that. So just like to share with you the platform that we have built, for example, the Favoriot IoT platform that will help in terms of this. We see that our platform is a service. So which kind of service? We call the platform as a service. For example, if the owner wants to build the whole infrastructure, the whole software, you manage yourself from the networking side or the hardware side, the CPU up to the applications. You are the traditional on-premises method. If you have the whole IT team, you can do that. But if you feel that you want to manage only the application side, and the below side is the infrastructure, because server always change, the OS always change. So you outsource this, managed by the vendor. So it's infrastructure as a service. So if you manage by the vendor from the networking up to the middleware, then you allow this, you yourself only focus on the data and the applications, then that platform becomes a platform as a service. So this is what Favoriot is. We allow other users to use the platform, create your own applications, own your data for whatever purpose that you want to do. So IoT platform also plays different categories. They have the people who are very big players, the Amazon, the Google, the IBMs. And then we have the open source, the community themselves that create the platforms. And then we have the end-to-end connectivity who create their own hardware and also their own platform, but it's not open. And then we have the developer-friendly category where they allow other people to use the platform and create their own applications. This is where Favoriot play a role. So regardless of whatever sensors down there, and if you have MQTT, you have REST, you have app, you can connect that into a single platform. So you can manage your platform. You can see the data that goes in and out of the platform, and you can extract the data out. You can create your own applications. This is what we allow users to do. So we have a lot of examples like tutorials and not all that for you to test on the platform. So we encourage you, the people who are out there who are build an IoT solutions or want to build in future of your IoT solutions, can use this platform. So it has different categories. For example, notification engine. You have your business rules, trigger certain thing, and it can come in many forms. It has its own dashboard. If you want to utilize the dashboard, it's already built into the system. You can do that. Or if you want to extract the data out and create your own dashboard, you can do that too. So when people ask me what kind of talent and what kind of knowledge that you want to build is through like the programming language, for example. In IoT, if there are about 14 top IoT programming languages. The popular ones depending on which area that you want to use. So if you're embedded devices, you might use C, C++. If you're working on the gateways, you might use Java or Python or C, C++. Or if you're working on the cloud, maybe Java, JavaScript, Python or PHP. And the most valuable programming languages, which is being defined earlier, they say that it's Java, Python, and C, C++. That's what they say. So it's easy for you to start off. You get whatever development board out there. Some is very simple. Some is already built in with so many sensors. And you can find either separate sensors or you can buy a kit which already have built-in sensors. For example, as simple as this, you have like Hibiscus. This is also a Malaysian IoT kit. It has its own sensors, the altitude, barometer, humidity, temperature sensors, or even accelerometer and gyroscopes is built in. So you don't have to plug and design your own. But if you want to put GPS, you have to create your own. It has its own Bluetooth or Wi-Fi, so you can connect to whatever gateway that you have, and then send the data out to a platform. And from there, you can create your own applications. This is how people build. So from that device with small kit, you can design into a commercial product. So if you already put a GPS device, you can, like this, SOS, man down, GPS, personal identification, two-way voice communication and all that. With a simple device, tracking device like this with different parameters, you can go out and solve different market. For road and railway construction workers, postal food delivery, for transport, bus or taxi, retirement people, the senior people, the social people, the social workers, the employee, the people who works in, field, the forest workers and all that. So it gives a lot of other opportunities in different market segments that you can sell your solutions to. So these are some of the examples that we have from environmental, and then we have these applications for smart city, or even from manufacturing. So we can have different applications. As I mentioned to you just now, when you go out there, you'll meet different kind of people. There's no single solution that you just plug and play. A lot of times need to do customization because different sensors is required, different connectivity challenges that you're going to face, different kind of platform that you need to choose from, and new customization of dashboard that you need to develop. So there are different components that you need to build to provide the whole end-to-end solutions. So it's very difficult for to say, hey, I have a plug and play solutions. It's not that way. So we are very grateful to see that there are more than 4,600 application developers who go on board to this platform from 111 countries around the world. So you can be one of them by subscribing to this. It's free for you to subscribe. So the technology will disrupt a lot of things. Yeah, it disrupt the whole industries. Here I just mentioned 20 industries. You just name it. Even the radio DJ is going to be disrupted by machines, by robots too. Yeah, teachers and college professors don't feel that you're safe, but be replaced by robots too. Okay, televisions have been transformed, libraries have been transformed, so farmers now also been transformed. So machines going to come and actually help you, making sure that. So guys, You want to be the innovators. This is the conference talking about innovation. You must be the innovators. Become also the early adopters. So you must trust the products that you have built, allow people to use it so that you can go across this chasm and become the early majorities. Then you can become really sustainable. Don't become the late majorities or the laggards. You are too late in the market. So how do we start? This is my last slide. Remember this. Start with small. Think big, start small, ensure that you have the right impact, get the buy-in, and then you can integrate with the current systems. And then from there, you can create more data, you can collect more data, you can create new business models, and you can have a better analytics. So with that, I would like to say thank you very much. I'll pass back to the moderator. Thank you.
Okay, thank you very much, Yang Berusaha Dr. Mazlan, for the insightful keynote address. There's so many things, new things to know. So now we open for question and answer. Please post your questions in the FB comments section. The secretary will relay the questions to me. Please also provide your name and also the institution that you are from. Okay, so I already have one question here with me. Okay, Doctor. Malaysia is still depending on more than 2 million foreign workers in jobs such as the plantation and construction sectors. Okay, how and when IR 4.0 can help Malaysia to overcome this problem and let the locals use IR 4.0 to replace these workers?
That's a good question. That's the reason why the construction 4.0 is being developed. One of the agenda is to reduce the dependency, our dependency towards human labor, also foreign labor. So digitalization needs to take in place. So it's a big program that they have from now up to 2025. But the adoption rate depends a lot on terms of getting the whole value chain in the industry to agree upon and understand that their impact of using automation can help them in terms of reducing that manpower. Of course, there are certain things which physically you cannot help. You need manpower to do that. But I must also like to say that you take a look at China, when they build the hospital during COVID-19, it's very fast, right? And you can see that certain, I think you have seen some videos that they can even build houses, 3D houses, 3D print within one day. You don't want to live, you don't want to buy a house and you have to wait for 3 years to live. So that's how when they depend on automation, technology like this, they can do that. I've seen some organizations who prefabrication certain things, and they use automation to really understand the just-in-time sort of thing. They understand when exactly that they need to bring in the concrete and all that to the particular construction site. So rather than you have to place everything on the construction site and then you have to wait for another couple of months for them to build. So they plan it very well. It's because they use digitalization extensively. So to move towards 4IR, ensure that a lot of things need to be digitized first. A lot of things need to digitalize. The workflow needs to be all digitalization. So in construction 4.0, building information management is very key. So they have to start from planning up to the point that they deploy.
Okay, so there's another question here. Thank you, Doctor, for the answer just now. The next question will be: the Internet of Things ecosystem requires a high cost for application. In Doctor's view, is this a factor influencing the slow adaptation of technology?
Yes. One of the main reasons of the cost is very high is because the volume is not big now. And that's one, because we need the volume to reduce the cost. So it's like a chicken and egg. Since you don't have that demand, a lot of demand, so the cost of production can be very high. Until a point that we can ensure that we have that volume, we can reduce the cost. Another thing is that a lot of users, when they request certain solutions, they need to be customized again. So it's not like off-the-shelf product that's out there. Whenever you do that, the cost of the initial production is still very high. So it's not like a common product that you can buy off the shelf like consumer. Consumer products is always millions out there, already out there, which you can plug and play. So because IoT can either go to the manufacturing sector or the consumer sector. The consumer sector is difficult, it can have a lower cost because volume is there, but it's very trendy. You need always to change that. But in the manufacturing and the industrial sector, it is very unique. All companies have different machines and they need to be retrofit. So the cost of initial investment is always high. So that is always a challenge. Yeah.
Thank you, Doctor. Another question here. The question is from Justin Leong from Sekolah Menengah Kebangsaan Ungku Aziz. Okay, his question is, what is the main focus of students during this pandemic so that they can be relevant to IR 4.0 after they have completed their SPM?
Okay, I think it's always about understanding the upcoming trend. Yeah? Understanding upcoming trend doesn't necessarily you have to go in deep, especially for the students who just finished their SPM. So you might not understand the in-depth, the integrity or the details of the technology. It's okay because you will learn that in the university. What's important for you who have already finished your SPM is to understand the basic, the understanding of the overall trends, what's coming. So you take a look at the 4IR technology. There's so many things, and even myself is not able to read everything. So you might understand like the 5 fundamental technology that you are interested in, like IoT, AI, big data analytics, cloud computing, virtual reality, and all that. These are the new technologies, the trends. You got to understand that. So learn that because that is the one that's going to be your choice when you take that in your university. Yeah? So in which area that you want to be good at, or what kind of career that you want to be in. Yeah? Because if someone is good in developing the applications, you might be going to the computer science side, the school of computing, which are more on the computing side. But if you love the idea of building hardware hands-on, then you take a look at the electronic side. So IoT is one of the places where you understand about the new connectivity, the new way of building electronics. So you have to understand that. So there are various components because the problem is when the students, when they go into the university, they didn't realize that, what are the technologies out there, and they just simply choose one particular area, which they didn't know where this area is going to be, what kind of career that is going to help them. So then they need to understand that. So that's why I think the jobs of the future now is to help you to understand that these are the relevant technologies that are going to take in place. So like I say, for example, like AI and IoT is two technologies which is very closely coupled. They can marry each other. So if you work on IoT, you might be learning AI later. Or you want to learn AI, you might find a way of how to collect the data. You have to learn IoT together. So it's like, that's why they call it AIoT. So there's something that's new. And then there's blockchain. Blockchain is also applied in IoT. So you have to understand what is blockchain is. So it's a distributed ledger, so no one can change or hack into the system to ensure that your information are very well secured. You can have a secure transaction contract that's going to happen using blockchain. But how to trigger that blockchain process is triggering through IoT. IoT, once it reaches a certain threshold, it triggers certain thing. So once you reach to a certain place, you need to pay a certain thing, it triggers the payment. So payment will go to another technology called blockchain. So that's how you need to read the whole technology span of 4IR in general. Then you will get to understand more detail when you are in the industry. Thank you.
Okay. Thank you, Doctor. Hope that answers your questions, Mr. Justin Leong. Okay, next question is from Mr. Muhammad Mirza. Okay, the question is, what is the role of Internet of Things in reducing the gap between university products and the need of the industry and also the market?
Okay. Can you repeat back? Because it's it's very something different question. Can you repeat, Nurin?
Okay, what is the role of IoT in reducing the gap between the university product and the needs of the industry and the market?
Maybe the question is slightly different. It doesn't mean that IoT can solve everything. First, don't think that IoT can solve everything under the sky. That's one. All right. But what we are seeing now is that IoT gives you an opportunity for the product to be well defined. Yeah. So as I mentioned to you earlier, a lot of products that goes out there from the university to the industry doesn't solve the right customer's problem. And you need to talk to the industry and ask them whether this is the right problems that they are facing. Don't build an IoT solution just for the sake of building it and asking the people out there to use your solution. It might doesn't work that way. It can, but most probably it doesn't solve, or you might have to refine again. Ask first the industry about their problems. Don't tell them the solutions. Ask them about the problems. The problems that you need to ask is what are the problems that you are facing, what data that you required, and what are the results that you want. So the questions are who, what, when, how, and why is the things that you need to ask them. And from there, if you take a look at the data you need to collect, is that these are the kind of data that you require. So, for example, if you want to find the right who, you might put a RFID. You want to know about where you put GPS. So once we have put these relevant sensors or define the relevant sensors, you need to build a prototype based on that to collect the data. So once you have to collect the data, in the universities, you have to develop an alpha version, meaning in the lab. Doesn't work in the beta prototype. In the lab, everything looks good. But once it's out there, the customer's premise might be located somewhere. It's very challenging for you to even incorporate a connectivity. So issue of connectivity like cellular is not there. Wi-Fi is not there. Internet is not there. So how do you want to collect data from something which is very remote? That's another challenge. That's what we call the beta. So the university have to come in and understand the challenges of connectivity too. Yeah. So when there is no coverage, what kind of alternative that you want to find? So new networks like LP1, you have LoRa, you have Sigfox, you have NDB IoT that can solve the problem. So you got to understand also the challenges of who want to deploy the network. Is it the telco, or is it someone is private? So these are the real challenges in the industry that they're facing. What you are doing in the lab might not be the same as what they're facing out there. So work together, start from ask them earlier, develop a prototype, and then show them. If it doesn't work, we have to refine that again. So you have to do it more agile.
Okay, Doctor, one last question from Ammar Azlan, a PhD student from SOC. So his question is, what are the government's initiatives in encouraging IR 4.0 and how can we take advantage of them?
Okay, so there are several initiatives that the government, I think a lot of people, one, they're asking for a support grant. Yeah. So MITI, for example, MITI have set up a grant where you have this intervention grant. So in order for the SME to transform themselves into 4IR, they need to apply for the grant. But before they apply for the grant, MITI would like to know, where are you now? assessment. So they do a 4IR assessment. Which level are you are? If you are 2.7, 3.0, 3.5, it's good. You're going to move towards 4. So what are the gaps required for you to fill in? So they have a grant, a matching grant. You apply, you will get it, you transform yourself. There is another grant, what we call NTIS, National Technology Innovation Sandbox, for regulatory purpose. So you have autonomous car, where you want to place and try your autonomous car. You have drones, where you want to fly your drones. So you have a place, a sandbox for you to pilot trial your project. So they have a grant on there. So NTI's sandbox grant. So you apply that grant. So mostly have IDANA grant. So they have that one, that two. So there are different grants which are TRL level. So if you understand technology readiness level, TRL, you start from 1 up to 9. So depending which TRL that you apply. So it's not very conceptual level. At least you have something algorithm. So you can apply this project in TRL 3, for example, or TRL 2 from the algorithm 2 or 3. Then you start off to build a lab prototype. You go to 4, 5, or 6, and then you go up to a beta prototype 7, 8. You might have standards. You need the product to do your standards to ensure that it fulfills the standard. So you apply for that grant. So they have different grants in that phases. So this is what the government is helping now, mostly for the R&D grant, and TIS mainly for the commercial and understanding regulatory. The SME, the OIR for committee is more for the SME part. That's it. Thank you.